Yeah, I think coming to Stanford showed me like how big it is possible to think. Like I love working on engineering problems, and I have since I was little and throughout high school. But I think when I came to Stanford, I started to realize like how an idea you have can actually sort of scale and impact the world in some way. And it's been really energizing and inspiring to kind of be surrounded by people who would be, willing to put in the 1,000 hours that it takes to kind of bring a project over the finish line and have it actually like impact people. So I have found like every day at Stanford to be full, like from early mornings till late into the night of just like building and collaborating with people here. So that's been my experience.
Hi, I'm Emma Zareen, your host and a 16-year-old engineering student, policy enthusiast, and hopeful future STEM school survivor. Welcome to She Persists. Before we dive in, I just want to take a second to say how grateful I am for each of you. Every listen and every bit of support genuinely means the world to me. When I started She Persists, it started as a little dream to share real stories of young girls in STEM who are challenging norms, finding their place, and inspiring change. Seeing that idea come to life has been so rewarding, and honestly, it's just the beginning. If you've been enjoying these conversations, I'd love for you to be a part of our community by following this podcast. It's one of the best ways to help us grow, share even more incredible stories, and connect with a wider audience. And I hope the conversation doesn't end here. I hope you carry these stories with you and let them be a constant reminder that your voice truly makes a difference. In today's episode, I'm joined by Stanford engineers Sofie Roux and Rachel Grant, two leaders of the Stanford Solar Car Project. Sofie is the team's solar array lead and the founder of Bloombox Design Labs, which creates solar-powered STEAM classrooms in Malawi. Rachel served as a mechanical co-lead, worked on Starship's propulsion system at SpaceX, and now researches the extreme conditions spacecrafts experience during reentry. We talk about rebuilding an engineering team from the ground up, racing a solar car after days of all-nighters, and learning that the best engineers aren't the ones who get everything right the first time. They're the ones willing to keep showing up, asking questions, and trying again. We also discuss what it means to be a woman in engineering without feeling like you have to be perfect, or give up the creativity and individuality that makes you who you are. So with that, let's get into it. Here are Sofie and Rachel. Sofie and Rachel, welcome to the She Persists podcast. I'm so excited to have both of you guys here with me today. And yeah, would you guys start by just introducing yourselves a little bit and telling me a little bit about yourselves?
Cool. I can go first. My name's Rachel. We're both at Stanford, but I'm studying mechanical engineering. Also did my undergrad here, also in mechanical engineering. I'm graduating in about a month, but I was one of the mechanical leads on Solar Car, large part of my Stanford experience, which is an engineering club at Stanford that I'm sure we'll get into. But yeah, I'm really interested in aerospace after graduation, and yeah, that's me.
And I'm Sophie. Rachel is one of my closest friends on the planet, and we got to kind of grow up together a little bit through being part of this very inspiring and demanding club. So we're excited to share that today with you. As for me, I study sustainable architecture and engineering, and I'm a senior, so also graduating this spring. The architecture school at Stanford is part of the civil and environmental engineering department, and kind of interfaces with like product design, civil engineering, and sustainable like energy systems. And on the solar car team, I'm the solar array lead.
Amazing. Yeah, I'm super excited to learn more about Solar Car and then about a little bit more about what each of you guys are doing as well. I'm super excited. For my first question, what has being at Stanford been like for you guys? Obviously, it has a reputation for being an extremely rigorous and challenging academic institution, but it also has a reputation of being a place where a lot of students are building and starting and creating a lot of really interesting things that are shaping a lot of what technology is moving towards and what STEM is moving towards. So, what has being a student in that environment been like for you guys?
So if you want to go first.
Sure. Yeah, I think coming to Stanford showed me like how big it is possible to think. Like I love working on engineering problems, and I have since I was little and throughout high school. But I think when I came to Stanford, I started to realize like how an idea you have can actually sort of scale and impact the world in some way. And it's been really energizing and inspiring to kind of be surrounded by people who would be, willing to put in the 1,000 hours that it takes to kind of bring a project over the finish line and have it actually like impact people. So I have found like every day at Stanford to be full, like from early mornings till late into the night of just like building and collaborating with people here. So that's been my experience. Rachel, what about you?
Yeah. Yeah, I think very similar. I think collaboration specifically, like in the mechanical engineering major as well as in solar car and engineering projects, I think it's really like fostered to one like come up with new ideas and like continue like always thinking. And I think collaboration is so important for that. And you meet so many different people and you get to hear so many different backgrounds and so many different interests. But the coolest thing is like there's no bound to your interests. It's like you can foresee all of them, whether you want to be like a writer and all maybe go build things at night or something. There's a lot of avenues to pursue that, and also foster that, like, collaboration with someone that's maybe interested in something completely different, but you learn from them in different ways, so I think that's been my experience.
Yeah, and I think engineering and STEM in general is such a collaborative field just because it's not something that one person can really do alone. So I think that's an awesome environment to be working in. What was the biggest transition for each of you guys going into an academic institution like Stanford from high school? What was the biggest shift or your biggest surprise or the biggest thing that you were excited about exploring?
I think a big part of going to college is learning not just about like subject matter, but also about like how to live, how to treat people, how you want to be treated. And I think a lot of that for the first couple of years at university was just trial and error. Like I made so many mistakes and like I don't know, I feel like it was a very, very intense time, both academically, but also just, like, spiritually, emotionally, and I think it makes, like, having really good friends or, such a meaningful team like Solar Car in my corner or part of my life now all the more valuable because those are, like, relationships that I feel like I earned and sort of nurtured, throughout my time. So, yeah, I think it was definitely, like, very overwhelming and exciting and intense at first. You grow a lot, like, as a person, as well as, like, managing all of the kind of trials and tribulations of difficult classes, but those are somehow, like, the smallest piece of the puzzle in terms of what is hard to handle, or at least in my experience.
Yeah, trying to think, high school was about, like, 7 years ago for me. I actually transferred to Stanford, so I went to Boston College my freshman year, and in itself, like, was also post-COVID era and everything, and I think, um so lots of weird things going on, but I think the biggest difference from high school is probably just kind of on the same realm of being able to, like, take ownership of your education and, like, choose, um like, really be the one to decide what you're spending your time on because your time is, like, the most valuable thing that exists, and so I think whether that's, like, friends you meet or, like, a project you care a lot about or classes you maybe weren't gonna take, but you wanted to and now you love that subject, but I think, like, it's important to, like, go down every avenue that you might even think is remotely something you're interested in and try it out, and I think, like, other than, like, a set course load in high school where you're, like, gotta get these grades in and things like that, I think thinking more on what ownership you wanna have over your education because you have, like, so much of it. Your education can come in so many ways. It can be classes, it can be research, it can be music, it can be so many different things, and I think, yeah, finding your niches.
Yeah, I think those are both really great answers, especially what you were saying about kind of like taking those interests and exploring a lot of different avenues, I think is really interesting because a lot of the best opportunities can come from very unexpected places or, interests. And then, Sophie, what you were saying about kind of like being able to explore and like being able to like come to that more of like a personal realization outside of just academics and education. And I think that's really important as well. So I'd love to hear a little bit from each of you guys individually. Sophie, would you mind if we start with you? Awesome. So you started Bloombox Design Labs at just 16 years old, with which you started designing STEAM classrooms in Malawi. So can you walk me through a little bit about like that ideation, the process of starting that on your own at such a young age, and then the journey that you've had so far?
Yeah, of course. We might need a 5-hour podcast, but I will say this super quickly. Um, yeah, I've always cared a lot about girls' education specifically. I think that if girls can have access to like very basic resources that they need, especially in like STEM and STEAM fields, the A for art, I think that sort of a limitless amount of potential will be unlocked. Higher rates of girls' education are tied to higher GDPs of like entire nations and slowed climate change and like all the good stuff that we want. And so I think I've sort of dedicated the past like decade of my life to try to like work on this problem in some small way. And I started when I was really little, just like selling artwork to raise money for different girls' education projects. And one of them brought me to Malawi, and I got to visit the site of a water well I'd raised money for by selling art. And then later, kind of like Rach was saying, COVID hit also during my high school experience. And it was just a time where like I got to um, think, sort of rethink about like what project do I want to take on right now that could actually be meaningful. And part of that was I'd made a friend in Malawi who wanted to be a Disney animator, but who went to school without electricity. And so I sold more art and raised money for a shipping container. And I just like asked everyone in my community I knew for help, like high school teachers and friends and family members, to kind of come into our backyard when they could and help me work on like wiring up this container into a solar powered classroom. And we ended up shipping it like across the world to Malawi, and meeting it there and turning it into a lab. And since then, we've put in 4 labs in Malawi and become a government partner. And what's been really interesting is like, as I was saying earlier, you might like come into Stanford with some idea or just college in general. But what's really fun is that like, and I found this is like if you pick one thing that is a problem that you don't get bored of, it actually like the deeper you go, the more doors kind of open up about things to be curious about. And so I just finished my honors thesis on making like recycled furniture for classroom settings out of like upcycled plastic. So I guess that is to say that like I have been interested in this problem for like 10 years, and it has been like interesting every day because of like being able to kind of grow with it and apply the things I've learned at college to it. So I think just being curious and asking for a lot of help has helped me a lot in my journey.
Yeah, and I think that's such a big thing that we oftentimes overlook, like having something that you're truly so passionate about that you find it interesting every single day, like you said, and you're constantly like learning more and finding new ways to contribute to that problem. So I think that's really awesome. So what you did was incredibly ambitious. Malawi's off grid, not a lot of reliable power. So how did you even begin to approach a design idea such as sending a shipping container across the world?
Great question. Well, it's a daunting task to think about like how can I, as someone sort of small and inexperienced, do anything that is like meaningful or helpful in any way. So I think as with any design challenge, and Rach and I might talk about this in terms of the car soon, but like it's about like really understanding the group that you're trying to provide like some sort of solution for. So I think like doing research, being sensitive to conditions on the ground, and knowing why you're doing it. So like all design should sort of be born from a sense of why and should be rooted in context. And that's something that is shared, that like design thinking idea is shared between architecture and engineering, I think, in a big way. And then from there, you prototype a solution and it might not be the best one, and you sort of iterate based on like feedback. So that's what we did. I gave surveys of students in Malawi. I kind of established a team on the ground to help me learn more about like what would actually be needed. And then we did some prototypes, like I made little models, and then we bought the container, and that whole process was like a learning experience, asking people who knew more than me. So I guess you take on a big challenge by addressing like many smaller challenges as you go, asking a lot of questions and being okay with like your first idea not being the right one. Especially like I was working somewhere so far away from where I grew up in my experience. And so the only way to do that well is to sort of I think be very okay with like not like knowing that you don't have the right answer, and sort of being open to like feedback from the place you're working.
Yeah, and I think that's such a big thing in engineering, especially is, when you're creating a physical solution and, especially for something like what you were doing, where, like you said, it's so far away from where you are and it's hard to see like the real implications that it's having on an everyday basis when you're not actually physically there. So having that mindset of like being able to adapt to things that you might not have seen coming and then building that into like an even better solution is definitely super important. So as a sustainable architecture and engineering major at Stanford, how has that impacted the way that you go about designing and building these bloom boxes?
Yeah, so with architecture, you start by just like drawing on paper, and it's a very like tactile experience with your hands, imagining like what a solution might be, and then like drawing and redrawing until you get something, and sort of modeling on a small scale what you think could be applied to the real world. And I fell in love with this concept of like ruralism in architecture. Kind of a fun part of the education in the sustainable architecture department is that you can specialize on these different tracks, and like one of them, that I chose as a focus was history. Actually, because I wasn't very interested in history, like, I sometimes don't think it's, like, that important to understand architectural history, because I'm really concerned with, like, the future, and, like, I'm excited about, like, architecture in space and stuff like that, so I don't know, I kind of went into it thinking, "Okay, this is one thing that, they gotta convince me is important," but I ended up learning about this concept of, like, radical ruralism that has been going on for, like, decades, where architects are considering like what the city means in relationship to the greater context of like a state or country. And like most of our countries are like agricultural lands, or like lands that are hard to reach or remote, that actually service the cities. And so I guess in thinking about like how to design in rural, off-grid, and remote settings, I've actually gotten to take a page out of the books of like some architects that I really like admire and respect. Like Rem Koolhaas is my favorite architect, who has kind of like dedicated the latter half of his career to like architecture in the countryside. So this is very specific and rambling, but I think what I'm trying to say is that it's that idea of like if you go deep into a subject, you might find something that is exactly like the framework for a completely different problem you were looking to solve. And it's really cool that you can kind of lean on the knowledge that exists to do what you do better and to apply it to like new and interesting contexts.
Yeah, and I think that's a really interesting thing that you were talking about a little bit ago, where you said you're very interested in the future and, space and space architecture. And then what you said about understanding the past really helps us look into the future too, and like understanding how they got to certain solutions and why certain things may not have worked even, and kind of like relying on that to actually build sustainable and like real world solutions to future problems. So yeah, I think that's a really valuable thing that you said. So I'd love to hear a little bit about your experience on the solar car team. So you're also the solar array lead on the solar car team. So can you tell me a little bit about that interest?
I'm interested in like solar power because, well, not because, I actually just yesterday learned about this term called solar punk, which is like this whole movement that I'm still trying to understand. But it's like this idea of how do you design a future that is like truly sustainable, where like everyone can flourish, regardless of like where they are in the world or like what their opportunities are. And the fact is that like we have enough resources and enough innovation already that we could just apply to like making the world and human experience better and better for the planet, and like very much intertwined with like the needs of our planet. So, solar power has been kind of a bridge for me between Bloombox and the solar car team. With Bloombox, I'm kind of in this like logistics role, where I get to lead this beautiful team that I have, who all carry out these very technical jobs to help like now bring these labs to scale, now that we're sort of scaling up. But with solar car, I get to kind of get my hands dirty, and be in the weeds with like actually working on a technical challenge, and kind of having ownership of the construction of a solar array system has been one of the hardest things I've ever done. And it's a role that I've really grown into. Like I think this past year I kind of hit my stride most with working on this project. And it's taught me a lot about like what being a good engineer and like leader means. And I'm still trying to figure that out, of course. But in terms of like what I actually do, so we have a car, and we're trying to run it like fully off of solar power. So you have your car and all the the mechanical pieces of the car that Rachel will talk about, and then you have the solar panels on top that are providing like the power, that feeds into a battery and then like drives the motor so that the car goes. But there are so many considerations like just in that kind of like energy capture part. The first would be like, okay, what is the, like, size of our array? And you're given these constraints by the group that puts on these, like, races that we compete in. You're given, like, a size, you're given, by virtue of, like, being given a size, you're given, like, a number of cells. The array goes from, like, the cell level to, like, a group of cells being a module, and then a modules coming together to make an array. And if you can pick the most high efficiency cell, then you create, like, a highly efficient overall system. First, like, I looked into what kind of cells we would need, and part of that is the logistics of, like, trying to get us access to those cells. Okay, then we have those. Then we have to do this process called encapsulation, which is where you put like layers of protective film on top of your cells to keep them safe. And that process has so much room for error. So that's something I've been working on. And then you wire the cells together in series and then into like larger groups in parallel that all have to like work together and be communicating efficiently. And at every step you can, you're removing moments of inefficiency out of the system. Like you're considering, okay, if it's a gray day, how are we going to get power to the motors? If one of the cells cracks and breaks, because you can imagine they're like thin pieces of glass, how are we going to bypass that cell so that the whole system keeps operating? So, anyways, that's my job. And this year, I've grown our sub team from like just myself to 8 members, which is wonderful with like a 50-50 girl like women men split, which is new for the team. And it has been like such a joy. And we're gearing up for a race in Australia, so trying to build a new car from scratch within a year.
That's amazing. And I'm super excited to hear more about it from both of you guys a little bit later. But I think that's so cool that, you kind of have that connection between solar car and then also your company and in that interest in like solar power and using it to create like these high efficiency either vehicles or like these high efficiency labs. So yeah, that's really cool. But
Yeah.
Rachel, if you're ready.
Yes, I'm
Yes.
ready.
Awesome. So you started at Stanford in a biomechanics lab, so like 3D motion capture, analyzing pitching mechanics, preventing injury in athletes.
Yeah.
So now you're doing combustion chemistry and reentry vehicles. So can you tell me a little bit about that experience between transitioning between the two fields? And then if you see like any similarities or connections between the two?
Yeah. Yeah. No, you're bringing me back. Yeah, so as I guess kind of my engineering interest story kind of starts like in high school, I never really knew engineering existed. I was like, "Oh, if I like math, I have to be a math teacher," and that's what we do. And so I kind of went down the pre-med track at a different university and ended up finding out about engineering and applied to some engineering schools. Ended up here, and yeah, that kind of started from I actually had a shoulder injury and started to do research on like one, figure out why exactly this happened. And that led me to research people have been doing on like analyzing essentially like the musculoskeletal body in terms of like a dynamic simulation model. And there's people doing some super cool research on like putting sensors on athletes and seeing basically where these sensors are firing too much. So that was really cool to me because I was able to go through that interest and figure out why exactly I injured myself. I played volleyball um, at Boston College my freshman year. And it was a large part of my life, and yeah, tore my labrum, and so yeah, I haven't really been able to like play at that high level anymore, but I still obviously enjoy it. And I think that led me to do research in the lab, and I loved it, but I realized that the biology part of it wasn't really what excited me the most. It was, yeah, the like data capture, data simulation, and the mechanisms there. And so started doing the mechanical engineering major, led into that. I've always been like a space nerd, like Star Wars fan, all of that, like my whole life. Kind of saw it as like, oh, that's like what all of those crazy smart people do. Like that's not something like I'm gonna be doing. And then like had a couple friends like in solar car actually starting to kind of do the stuff that I was thought was like a far reach goal, like work in aerospace from their experience and yeah, learning at Stanford. And I was like, wait, I could do that too. Like this is cool. And so yeah, got went through the whole mechanical engineering major and everything, but that was like a kind of the interest. Always going down your interest path is something I definitely recommend to anyone. Yeah, I have been doing aerospace things since then and plan to, but I got the experience to work at SpaceX last summer, work on Starship, which is like coolest project ever. And then what really excited me is I basically found out that there's this super cool lab next to the kind of makerspace that I work in at Stanford. So I work at the makerspace for like mechanical engineering students and all students actually at Stanford. But yeah, we have like a machine shop and things like that. But across the way, there was this shock tube lab that I didn't really know existed until I met one person last summer that was in the lab, and so I decided to check it out, and yeah, I got into some super cool combustion and reentry chemical kinetic things, which is just directly applicable to kind of the space environment and things like that, and figuring out those like really cool problems and fundamentals of existence and quantum mechanics and that sort of thing, which is really cool to me. But yeah, I think as you can tell, definitely down many routes and tried a few things. But yeah, I think everywhere I've learned something helpful towards the next thing. And so yeah, definitely not a straight line, that's for sure.
Yeah, and I think that's one of the most valuable things about like exploring different paths is that there's always something that you can pull from one experience to the next. And then kind of just like continuously building that like resume almost of like information in just experiences that you've had. And I think it just makes someone a lot more of like a diverse and more open-minded engineer as well to have like those different experiences. But my next question was actually about your experience at SpaceX. So, in between all of the work that you're doing, you also went to SpaceX for a summer and worked on a really crucial subsystem in Starship's V3 propulsion system. Can you tell me a little bit about that experience and what that was like for you?
Yeah. Yeah, it was definitely a experience. I think I yeah, went into it not really knowing what to expect. Obviously, we have our experiences like solar cars, like a project we're working on, and we all kind of believe in the project, and it's really cool to have that feeling. It was definitely a dream come true to be able to work on Starship and like feel that energy every day. I was in Starbase, so in Brownsville, Texas. So, never been there, but it was a super cool place, and I met some really cool people, and, yeah, I definitely took that experience as curiosity and learning as I could. I met some really cool mentors that taught me a lot about how to ask questions, how to ask good questions, and to ask questions, and, yeah, I think a few of the things that I took away from that experience are I think the relationships that you make along the way are definitely one of the most valuable things. I think, like, obviously good engineering is insane and super cool and also a big takeaway, but I think that comes with working with really passionate people that wanna work hard because they believe in the project. It's not like a forced thing. It's you're grinding towards something that you believe in that's bigger than you, and I think I could feel that there this summer. Definitely bring that into all of the work that I did this past year and everything. But
Yeah, that's really exciting. Is that industry something that you think you'd be interested in exploring further?
yeah, yeah, I think so. I think it's our duty as humanity to just be as curious as we can and just learn as much as we can because we'll never know everything, at least we won't. But I think yeah, I think it's definitely what I plan to continue to be curious about after college. Yeah.
Yeah, and I think the time period that we're in right now is such a like groundbreaking stage of especially space and like aerospace engineering. We're making like so many movements towards that kind of like getting further into space, making these new discoveries, going all the way around the moon or landing on the moon. But there's just so many exciting things happening, and I think that's a really exciting field to be studying right now. So now at Stanford, you mentioned a little bit about the lab that you had found across this from your makerspace, but you're in the lab studying chemical kinetics in hypervelocity shock tubes. So can you explain that and a little bit about the work that you're doing there?
Yeah. Yeah. So essentially, I guess one of the projects is on studying the chemical kinetics. Basically, if you were to break that down, would be measuring the amount of a certain atom or molecule that you care about and simulating that condition in a shock tube. And so the Stanford lab, the Hansen lab, is one of a few in the country that can simulate these conditions. And so being able to create those conditions in this setting allows the lab to research a lot of kind of the like if you had like researches here, this lab can get like the kind of the rest that is kind of impossible to simulate in other ways. But yeah, I guess one specific project that is actually on campaign right now, but it's studying the amount of excited oxygen because excited oxygen that a reentry vehicle would experience when they come down through the atmosphere. And they're simulating it actually in a shock tunnel in Caltech right now, but um yeah, basically measuring that amount of excited oxygen can directly correlate to the radiation that a vehicle would experience. And so, yeah, working with industry and using this data to kind of further our understanding is the goal of that. Yeah.
Yeah, so you're currently graduating from your master's. Do you think, or at least I guess you still have time to figure it out, but are you more interested in like the industry side of aerospace, or the more like research, academia side of it?
Yeah, I think I'm definitely more interested in industry. I think Stanford is a very research oriented university, and that's great, and it's been able to teach me a lot of things that I wouldn't have learned otherwise. But yeah, I think the industry applicable thing is what I plan to start with at least. I can be a little impatient, and so I think getting that seeing the hardware, working closely with it is where I want to learn the most.
Yeah, that's awesome. So I'd love to hear from both of you guys now about the Stanford Solar Car team. So Stanford has, no shortage of project teams, rocketry, formula racing, satellites, you name it. So what made Solar Car the team that you guys wanted to join, and like what made it stand out from others?
I can go. You wanna go? Okay. Yeah, I think I ended up joining because a good friend and kind of mentor for me in the teaching lab that I work in now, he also worked there and he kind of told me to come by. And I came by and just kind of started doing projects here and there. I think I did try out some of the other engineering clubs, and the cool part about Solar Car that stood out to me was kind of the camaraderie of kind of the small team, and also like the workspace, being able to work on this one car and see all of these people that I very much respect and everything, like my friend and things, like caring about it so much. I think that kind of drew me in, that like small team setting, and yeah, kind of went from there.
I think for me, I had watched a like documentary about the solar car like race before applying to Stanford. I remember I watched it with my mom and she was like, "Oh my God, if you get to go there, like you gotta talk to those kids. They seem amazing." I did. And actually the Stanford Solar Car team was kind of on probation when I joined. So I joined in my freshman year and we had been sort of benched, so to speak, that year just because we had like an incident with our car during a race that became unsafe. And so we weren't allowed to touch the car for an entire year. We didn't even have workshop access. And so what's interesting is that all the people who had built that original car that we could see and like touch and sort of not work on, but we knew it existed, they had graduated that year. And so what ended up happening is I had joined this club that like I was so excited to go to Australia with right away and like get to work on the car. And what it actually was like a very small group of people um, knew that like this was an awesome team, but who had never gone to Australia, whose like mentors had graduated or were graduating, and had to kind of rebuild. They had to rebuild from there. And so it was like this very interesting time because a lot of people got bored and they stopped coming to meetings because they were like, okay, I'm going to join the space team. They actually launch rockets. That's awesome. I didn't really like think about myself as like an engineer being on an engineering team. Like I didn't. I liked robotic. I had an amazing high school teacher who led a robotics club in high school, but I always felt that it wasn't quite for me. But for some reason, like just this like underdog thing that was happening kind of drew me in, and I kept sticking around and coming to meetings. And what happened was that like by the end of my freshman year, um, the very last kids who had helped build that car they were graduating and they were giving up their roles, kind of like a lottery. Like, okay, who wants to be the mech lead? Anyone who raised their hand could be the mech lead. It was ridiculous. And so I got my first position that year, just sheer luck. But I was so excited. I was like, oh my God, they want me to be the safety officer? Like, that's the most important thing ever. It was not, you know what I mean? But like, that really hooked me. And so I stuck with the team And a year later, when Rach like joined, that was the summer that I got to be a driver. Because like there were not a ton of girls on the team. And the boys were all like heavier or like had broader shoulders than me. And so for that reason, I got to be like there was like myself and one other guy who was also shorter and smaller who got to be the drivers that summer. And so then I got to start telling people that I was a race car driver. And so then you could not rip the team away from me if you tried, because that was super sick.
Yeah, that's so awesome. And I think something that's really important that I guess you could kind of take away from the experience you had, at least, Sophie, is that, sticking around even when, you might not be seeing an end result right away. I think that's such an important thing in engineering. And just you showing up and like staying with the team, even when you guys weren't necessarily building the car or working on it. I think that's just such an important like life lesson too, is that sticking with things can really take you places. It's really awesome. But, for listeners who've never seen a solar car race, can you explain a little bit about, like, what actually happens there, if there are specific, criterias, and what that experience has been like for you guys?
Yeah. Rach, you wanna do it?
Yeah, well, I'll give my experience, and then Sophie can kinda give her driver experience probably, and strategy and all of the above, but yeah, essentially you work really hard on a car for a number of months, and you're in, like, constant communication with the scrutineers, which is what we call the people that are kind of inspecting our vehicle, and we have a set of regulations, and so we're meeting those regulations on deadlines and things like that, and then we have a whole transport of the vehicle, like a trailer. Some schools are even close enough where they drive their solar cars to the race. Sophie and I have been to like a track race, so it's like there's a few different types of races that she's talking about the one in Australia in now a year, I guess, which is the World Solar Challenge. We took part in the American Solar Challenge in the past year or so, which starts with a track race. So you basically get your whole team, get your car to this campsite essentially next to a track. And for about like 3 days, you're going through each of the inspection checkoffs. So there's an electrical one, there's a mechanical one, an array step. And so going through each of these steps, making sure your vehicle's passing, and if it's not, then going and fixing it until you basically get checked off to enter your car into the track race. And then it's definitely very different than like a formula race or something like that because it's an efficiency race, and so it's set time to charge your array in the morning, and then it's a full day of kind of long hours of driving and cycling your drivers and constant communication with your drivers, and then a set time after to charge as well. Take the battery out of the vehicle, and yeah, the track race is about 3 days long. And then if the American Solar Challenge is happening that year, then you essentially can qualify for that, which is a longer trek across the U on a pathway that the scrutineers set. It's camping along the way, it's making food, it's, following your driver, and things like that.
That was a perfect summary. I think the only thing that Rach left out was, like, how, like, tough it is to just, like, be there and, like, support the car. Like, the conditions are, like, kind of intense. We've yeah, so like Rachel said, we went to the American Solar Challenge, which for the past, like, 2 I guess there's the American Solar Challenge and then the Formula Sun Grand Prix, and they were both held in Kentucky, um, at in a place called Bowling Green, which Ridge and I had not, like, been to before, and you fly into Nashville and then you drive to Bowling Green, which it feels a little bit like it's in the middle of nowhere, but what's fascinating is it's like a car lover's heaven because it's, like, right by the National Corvette Museum, and so you see, like, these beautiful race cars just, like, being driven around this track. And in the days leading up to the race where you can't get on the track and you're just getting your car checked, you might like run into like real car heads who have like come to drive cars on this track. But anyways, the first year we ended up camping on the parking lot, like right outside the racetrack, which was insane. Like, Kentucky is so hot in the summer, and then there's, like, these fast flash floods that will, like they would just come down, like, wash out our campsites. Rach and I shared a tent the first summer, and we were working so hard that, like, by the time I would be going to bed at night, Rach would be, like, getting out of the tent to, like, pull an all-nighter working on the I guess, like, the brake lines of the car, and then I would wake up and start working on the array. So, I think in that way, we had people working on the car, like, 24 hours a day, eating very little, like, just trying to survive, like, wet clothes sometimes, like, just sweaty, like, just gross, like and you're in this parking lot with, like we don't have a car, like, that we could just, like, go somewhere else with, so you're kinda stranded. But what's beautiful is, like, you put these kids in that scenario, and they just, like their power is, like, unleashed because it's, like, pure focus, and the goal is, like, right there. It's, like, getting on that track, and, like, some really good engineering happens, and I think what we saw is that there's also a lot of, like, camaraderie and, like, kindness that comes out of a situation like that. We still have, like, really good friends from this team called App State who would, like, take parts of their car off of their car to give to our team to use or would, like, give us space under their cover when, like, it would start to rain and we didn't have that. And so I think that kind of, like, intensity and sportsmanship that we saw out there also makes these races something that it's, like, very hard to capture or explain outside of it.
Yeah, that's really interesting. I'm on an FRC team right now, so First Robotics, and there's this thing called gracious professionalism. So it's basically exactly what you were explaining. Like, obviously, it's a very competitive environment. People are there to win, but there's also that sense of like sportsmanship and like you just said, kindness just between teams. So yeah, I think that's such a big thing in engineering, especially in competitive environments where it's like, you're all kind of going towards this very similar goal and having like an outlet where like people are looking out for each other and like teams are kind of working together in a sense, whether that be directly on the car or not. I think that's really valuable.
First robotics thing, are you like, how long have you been involved in that? Or, like,
Oh
what are
yeah,
you get
I was mentioning this to Rachel earlier, but that's actually the reason that I part of the reason I started this podcast was I joined 2 seasons ago, and so this upcoming season will be like my third year. But I was the only girl on the team out of like 18, almost I think it was 20 people, and I was the only girl that they've had in like a few years. So engineering has always been something that I've been interested in personally. So going into that environment and being like the only girl in the room was a little bit like sad to like not see that representation. So this year was actually a lot better. We had 6 girls. So that was really nice to just like kind of get to see people joining this club that they find interesting. So and I think part of the reason that happens is that sometimes people don't even know about these opportunities that exist or like these kind of like avenues of exploring their interests. So, yeah, so this podcast kind of like sprouted from that and being like a place or like a platform to create an opportunity for younger girls in high school and college to kind of share their experiences as they're still like figuring things out and getting established into their interests. But yeah, so I mostly focus on mechanical, though I do a little bit of, like, electrical, but yeah. So, it's been very fun.
It's
Yeah,
incredible.
keep going, keep
Yeah,
going.
and I don't know I don't know why it's like this and, like, why even, um, like, Rach and I have had experiences, like, where, we believe there should be more women in the room, like, even at someone where, like, Stanford, where you think, like, they should have it all figured out by now. Uh,
Yeah.
but and then you look at the like, I think it's, like, 15 or 16% of women, or 16% of engineers in the US are women. It's lower where I'm from in Canada, like, those numbers aren't random. They're like a product of like these compounding, like at every level of engineering from like elementary school until like you join the workforce. It adds up every time. Like, and I think that we're sometimes sensitive to like the small ways that we get discouraged as we should be. And it can close doors. The point is that like we need all the best engineers to be solving like hard problems and not just the like loudest voices either. So I think it's great that you have this podcast. Rach and I saw your email and we're both like immediately
Thank
yes.
you so much.
Yeah.
It's so important.
Yeah, and I think it can oftentimes be, like, a little bit scary to be, like, one of very few girls in an environment.
Mhm.
So having, I guess, like, kind of like a way to handle that. And just like hearing stories from people who've been through similar experiences is part of the reason I thought this would be cool. But yeah, you were mentioning like Stanford. I go to like a STEM focused high school right now. So going into there, I kind of expected that I would see more, I guess, female representation in certain STEM fields like engineering. But I'm in a robotics class right now, and we actually have 3 girls out of a class of, like, 25 people. So, it's just, like, things like that where, there's definitely shifts that are happening, and we're definitely seeing, especially in, like, industries, and seeing a lot of amazing women move into these really big roles and making these great discoveries in STEM and other fields as well, but, I think there's still a lot of work to be done, so I'm glad we're moving towards that.
Yeah.
Yeah.
It'll be nice to have, like, people at your school who can, like, look up to you too. I know, like, Rachel is my peer and my teammate, but she's also 2 years older than me or, like, higher school level than me and has, like, genuinely been, like, a role model, for me, and I wouldn't have taken some of those steps that I have without her, like, showing that I could. So, very
Yeah, I think that's
important.
such
Role models work both ways.
Yeah.
No, but yeah, I think, um, like, one of the most important things, I guess, in any advice if I could give is, like, I think one something that I've definitely struggled with when it's, like, there's just 2 of us, like me and Sophie or just me, like, in a room of guys, I think, like, it's easy to focus on that part of it, but that's only kind of taking you away from, like, something super cool, and I think it's it's easy to think like, "Oh my gosh, I'm the only woman here, like, that means I have to be perfect, and I'm, like, representing all of us." But no, you don't have to be perfect. You're gonna make mistakes, everyone's gonna make mistakes, you're gonna and that's the actual best way to learn, the only way, and, yes, like, that, like, extra pressure that I tended to put on myself, still do, to kinda be perfect, I think is something that we don't have to be. Just gotta be try to learn new things and do what yeah.
Rach so right, like, it's not and it took us years to learn this, but at some point, it's not like a number of girls versus number of boys thing, it's just a being a good engineer thing, working on, like, a problem that matters, and, like, we've seen that it's sort of like it's easy to take, I guess, like, moments that might be uncomfortable and, like, contextualize them as, like, "Oh, well, I'm a girl," or, like, "I made this mistake, and, like, that is terrible, and, like, they're gonna think I'm dumb because" but, like, that is not your burden, like Rachel is saying, and also, as soon as you put in the hours to actually contribute meaningfully to solving the problem, I think those, like, gender barriers have a better likelihood of dissolving because then you're seen not just at like face value, but actually for like the work that you're contributing. And I would say on that too, like you don't have to change like how you are or how you act or your gentleness or your sparkle or how you want to dress or present yourself. You just have to contribute to the mission of the team. And you being yourself and being unique will actually bring something like really helpful and different and new to the team that it will need.
Yeah, and I think those are both such great points, especially what you were saying about, like, not just focusing on that fact that, like, you're a girl in this group of, like, all guys. But I think it's really easy to kind of, like, get centered on those kind of surface level things. But, like, behind all of that, you're still, just an engineer or you're a biologist or you're a doctor. And I think it's so much more important to focus on, like, that skill set that everyone has, like, equal access to. And, like, everyone is able to put in the same hours to kind of like get to the same places. And I think once you kind of shift that mindset, like you guys were talking about, from, being, oh, like I'm the only girl here, to being like, if I put in the same amount of work and the same amount of effort, like I can achieve the same things because I'm not any different just because I'm a girl. And I think that's like such a valuable lesson that obviously takes a lot of time to like actually get behind. It's definitely a lot easier said than done. But yeah, I think that's a really great message from both of you guys. So, Sophie, you told us earlier a little bit about your work on the solar array and kind of a little bit about what your role as the lead for that entails. Rachel, would you tell us a little bit about your role as the mechanical co-lead and what that contributes to the car? Any specifics or?
Yeah, so kind of as Sophie was mentioning, the time the past few years, not this year, thankfully, but the years prior were working on a vehicle, dealing with loss of institutional knowledge on that specific vehicle, and really kind of that underdog story. And so, yeah, my time as co-lead was a lot of rebuilding the team and teaching new members, separating projects and basically trying to scrappily get a lot of things done. Maybe some projects that I didn't start, kind of finishing things and kind of being able to prove ourselves as a team. And so yeah, I'd say yeah, basically the mechanical team. Now the team has been able to split it into different different teams, so like dynamics, aerodynamics, and like battery as well as structures. But yeah, when I was co-lead, all we had was mechanical, which is in charge of all of the mechanical components on the car. And so a lot of our projects were very like we can't drive without this part on the vehicle. And so some of those were basically we Sophie and I have been to two races, so 2024 and 2025. 2025, this past year, we got second, which was super cool. So we were able to kinda show off the reliable parts of the vehicle, but 2024, was kind of our scrappy summer of doing the, like, composite layup of the canopy, what goes over the driver's head, like installing the roll cage and really scrappily getting all of these projects done to be able to get this car to the race. And then the next year, our big focus is completing a reliable vehicle that's going to be able to basically earn our spot as a well performing team. And so that's what we were able to do last year. We basically like replaced new motors and also designed like me some coolies and our members as well, kind of building up that team as well. We worked on implementing new motors in the car, new brakes, and yeah, lots of other projects around that. But yeah, a lot of it was building up the reliability of this vehicle and the kind of institutional knowledge on the team to be able to get to where the team is now, which is super exciting, being able to break up sub teams, design a new car finally after like six years or so. And so yeah, it's super cool to be able to see the new members now kind of taking more leadership roles and being able to focus on the engineering problems that we didn't get to focus on due to like being able to work on the car for one, like time constraints and yeah, just like being able to optimize things from the beginning and those requirements rather than a vehicle that had the original kind of chassis, which is like where the driver sits, the suspension, and the aero body had been done in 2020. And so being able to be a part of that design challenge from the beginning this year has been kind of what Sophie's been working on and some of the new leadership. But yeah, so proving ourselves as an underdog.
Yeah, that's awesome. And congratulations on second place. That's huge. And then, Sophie, I don't know if you wanted to add anything about solar array. I know you touched a little bit on it, but if you have anything else.
I think like one thing that Rach kind of led to at the end there was like we are designing a fully new car now, and what I didn't expect to happen, or like what I'm learning, is that all the systems are like so integrated. And you can't make it really a single decision by yourself because they have impacts on like every other sub team or part of the car. One example I can give is there was big consideration of like the aerodynamics versus the array. And so if you think about it, you're trying to have the most efficient car, and the shape of an efficient car might look very different for aerodynamics than it would for the solar output. A solar panel works best if it is like perpendicular to the incident like sun rays. And so in like on a sunny day, having like almost flat array is ideal, or like matching the angle that the sun is hitting the panels at, but definitely not having like a curved top shell. But of course, like for aero, it's the opposite. You'd want to have like a bullet piercing through the air. So when you kind of are trying to balance out the two priorities, there's a lot of measurement and testing that you can do to get like kind of narrow in on a solution that works for both groups. So that's been interesting, like doing like characterization of the cells themselves to see like how much can they bend without losing efficiency so that we can like have that trade-off work. Also, just like thinking about how with the other components, like the driver sits in like this bubble that shades the array. How can we design around that to make sure that shading won't like catastrophically cause the array to fail? So what's been really fun is like we've sort of ramped up our inter team like sub team, and that has allowed us to really debate these issues together and come to solutions. So I think that's been good. And then the other thing, like Rachel was mentioning, is like training up new members is so fun. And since I'm graduating and I won't be a Ray lead, one, it's like a super weird feeling that like it won't be part of our like labs more, but also like knowing that the next generation is ready to handle it is gratifying, and getting them to that point has been like a big focus too.
Yeah, that's awesome. And I think that's such a big job as like roles, which I think obviously you guys did a great job at, is like making sure that not only the car is being built well, but also like the younger people who are just joining the club are also like well equipped to maintain the club after you guys are gone. So yeah, I think that's such an important like leadership characteristic. So yeah.
Yeah, I think one thing that was really cool about our team, and I'm sure other college engineering teams as well, but it really doesn't take, obviously it's great when like someone like you has done robotics in high school and things like that, but it doesn't you don't have to have any background at all. Usually it's freshmen who come in who um maybe don't know what they want to study or haven't taken an engineering class, but you can kind of jumpstart some hands-on learning, and maybe you find out like usually there's a place for you on the team, whether that's in strategy and debating efficiency of what the car how the car systems are working together, or that's hands-on like manufacturing of mechanical components. But wherever that is, like there's a place for all interests and all backgrounds, and I think, yeah, treating it as kind of a learning opportunity and seeing what you like is super great, and obviously, robotics is really cool in high school too.
And I feel like having that opportunity to explore new kind of like fields, like you said, a lot of the times people come in not knowing what they want to study. But I feel like learning through a hands-on experience is almost sometimes like the best way to explore a new interest, just because you're really able to see the implications and like how something is applied outside of just, a classroom, and like a class, and the things you're learning, of course, are extremely important conceptually, but seeing how that's actually applied, and then being able to, in a club like like the one you guys are a part of, like seeing the work that you put in, like actually being raced, and like seeing that end result can be so exciting. So yeah, I think hands-on experiences are sometimes like the best way to learn, and having that opportunity to join completely like fresh off the bat, having no experience, is so valuable.
And I think, like, one other thing that I've seen, like, just in myself is, like, you can take a lot of classes and, do a lot of math and physics, but I have found myself being more, like, what is the word? Practical. Like, I've become a practical engineer where, like, I will, like, I don't know, I know how to communicate what needs to be done clearly, and like, how to organize like a project timeline so that something gets done and like the right people are helping on it. And I think that kind of engineering skill that's super applicable like in the industry, I guess, is something that you can't necessarily get out of a class. So I think it's sort of those skills that you can't necessarily quantify that I think come out of working on a project like this too.
Yeah, I totally agree. So, what has been the most chaotic and the most exciting moment for each of you guys on the team?
I think we might have the same one. What do you think, Sophie?
Wait, that's a crazy statement. What do you think it is?
Well, I'm thinking of summer 2024. What are you thinking of?
Wait, yeah, true. I was just thinking of different moments from that. Yeah,
Yeah, there's definitely a lot of moments.
I think I think the moments leading up to getting our car on the track in 2024 were insane. We were not ready to get on the track, and we actually didn't pass scrutineering until like a couple hours before the race was going to be over. Um, which was funny. But what was really cool was like how hard every member of our team tried to get us ready. I'm really proud of our team, and I think like that summer and like trying that hard for each other. I think that's what makes us like all really good friends, like, for life, which is weird to say, but, like, we all, like, tried that hard so that each of us could be successful, and, like, now I think for Rach and I, like, the kids we went to the race with that summer are still, like, our favorite people on the planet. But Rach, you say your moment because I have one in mind that's slightly different. So you
Yeah, no, I can think of a lot of moments. I'm only thinking of the word chaotic, and that comes up. Wait, no, share your other moment, and then I
my
can.
moment was gonna be, so with those couple of hours to spare, like, when we did get on the track, I was driving, so it was, like, a really crazy experience because I got to drive this car that, like, everyone had stayed up day and night to make work, and, we were, like, being cheered on by pretty much every other team just because no like, everyone knew we weren't gonna win, we weren't even gonna place, but we had, like, really tried to get on the track, and in the days leading up to that, like, there had been buzz around our team because everyone knew, like, that our car wasn't working, and they were kinda rooting for us, which is unusual in a competition. And I remember, like, getting in the car and, like, really feeling like I wasn't alone, which was cool, like, cause all of our friends were, like, so exhausted and so excited that we'd gotten on the track. One chaotic moment was that, like, the epoxy from the, like, part that had been glued on the car not long enough earlier, epoxy was curing and smelled like fire, and so I made, like, an I, like, ejected myself which was ridiculous, but, like, I was like, "This is amazing, I'm so proud of us, but I'm not ready to die," and so I, like, ejected myself, and rage came, and we were like, "What is going on right now?" And then the race ended, so it was, like, this weird, like, letdown at the end where, like, I just stopped driving at some point, but, no, it was beautiful. Brings tears to my eyes.
Yeah, yeah, I think, um that summer was definitely probably the most memorable part of the team. It was, like, 10 of us, 10 plus a few more, like 15 of us at this race or something, and we all had, like we didn't there was a lot of parts of the car that we didn't really understand, didn't know how to work, one being the brake system, but we really believed in the team and came around that. Some of these people I didn't even know before this summer really much at all, and then we lived in, like, a house together, got to this race, and it only started there. We learning a lot about the brake system, very hands-on. We had, like Sophie was mentioning, Appalachian State is our good friends, and many other schools coming over being like, "Oh gosh, do you guys need help? Like, how can we help you?" Uh, and we have people that did the same thing, like, designed their brake system, and so they were able to teach us and help us. Yeah, essentially what got us on the track um, was the AFSAPE, president, Zach Howard, gave us his old brake lines, to be able to put on our vehicle, like, last minute. He found them in all of the fittings because 'cause we've been having trouble with ours, and we put them on after just a few all-nighters here and there. Um, we put them on, and we were on the track on the last day, which is not usually allowed, but because of our communication with the scrutineers, they were rooting for us too, and they let us go on the track on the 3rd day, so everyone had already raced the other days, and we got, like, I think 7 laps or something. Then I'm on the walkie-talkie talking to Sophie. We just all switched from, like, sleeping in the trailer, like, working on this car to, like, we're on the sidelines with everyone else, and, like, everyone's cheering for us, and, like, all of the teams, like, they just they're, like, came and just looked at our car, and we're all, like, cheering for us as we got on the race for our 7 laps, which was really important to us. I think that moment was probably one of the best ones.
Yeah, that's amazing. And I think what you were saying about like you guys all having that belief in your team, regardless of, the situation you were in, is I feel like that's so important, especially on like these hands on engineering kind of situations. Just having like enough belief in like knowing that, you guys are going to figure it out and figuring out ways together to kind of like come to a way to solve the problem at hand. And I think that just makes it feel like less work and more just like something enjoyable that you're working on. But yeah, I think that's such an important like mindset to have in any project focused thing. But yeah. So
Yeah, and even if you don't
like
figure it out, you learn something anyway.
right. So for these next few questions, it's like a rapid fire round. So they're just really short questions. Give me your first thought. Like, don't overthink. But for the first one, what's your favorite class that you've taken at Stanford?
I took an ecology class that, like, kinda changed my life. I'm doing a minor in Russian language and literature, and we had to I don't know, I had to take this, like, elective in ecology that was about, like, how the world or, like, the environment and nature are affected by our choices, especially like in relationship to wars and colonialism. And we read some texts that like I probably would never have read just like because they're outside of like the engineering core or like architecture, like Omaris by Derek Walcott, which are just like that one's about like this odyssey from like Jamaica, like back to Africa that was just, like, so beautifully and poetically written that, like, made me rethink it kind of, like, added a new I've always cared about sustainability, and it added a completely new aspect onto me, and I sometimes don't realize that, like, I can learn something so radically new, and then I, like, took that class, and I was like, "Whoa, I know nothing, and this is amazing."
Yeah. I'd probably say mine is my, poetry class. I did a poetry minor, creative writing, in my undergrad, and it was completely different than any of my mechanical engineering classes, and they were basically, like, small group discussions where we would write poetry, learn about poetry, and then share our work with our class, and they were, like, definitely, like I looked forward to them every day, and I learned, like, how to express myself in another avenue, which was, yeah, something I still do and is very important to kind of, yeah, keep
That's awesome.
finding
Yeah,
those
I
little
think
things.
it's always important to have like there's interests outside of, like your main focus, like you're doing mechanical engineering, but poetry and creative writing in general is such like a great outlet and it's also like such an amazing way to like share your experience and like your feelings with other people too. So I think that's really cool. And then I love how both of the classes were like things that were kind of outside of your realm of focus in terms of your major. So yeah. But so what is something that you wish you had known before joining the solar car team?
I wish I knew, like, and electrical engineering skills because I've been a little bit self-taught. And that is hard, but I don't regret it because I learned so much.
I mean, obviously, other fundamentals, but same as Sophie, definitely a lot of self-taught things and subjects. That's a tough one. I know before. I mean,
Wait, sorry,
yeah.
what about you?
No, you go. I'm
I was just
thinking.
gonna say, like, I feel like that first summer, I felt like we always had to prove ourselves. Like, I feel like I wish I knew that, like, not every conversation has to be, like, a defense, and, like, not every project has to be, like, perfect. It's okay to ask for help. Sometimes I felt like I had to do things a certain way to, like, be accepted in the club, but now when I do things my own way and, like, collaborate, I feel like more a part of the club than ever.
Yeah, I think kind of probably along that lines, but, like, your project doesn't have to be the most perfect idea or thing built. And sometimes and a lot of the times in engineering and in the world and also, especially in, like, college, teams that you're balancing your classes and this team, it's sometimes you just gotta try one thing and then that you'll learn from it, and, yeah, I think sometimes, like, just doing the thing or just, like, giving something a try rather than, like, debating it, what's the right way, because every way is gonna have trade-offs, and it's great to talk about those things, but at some point, like, just getting something on the table and coming up with a scrappy solution can lead to something better.
100%. If you couldn't be an engineer, what would you be?
I think Rachel talked about this a little bit earlier, but I think I'd wanna be, like, a physicist and, like but, like, study, like, black holes or, like, the universe in some, like, philosophical way to have the time and space on my hands to, like, go super deep into a project, even if it doesn't have, like, obvious real world impacts. I care a lot about, like, if that kind of thing, but I don't usually have time to explore it.
Yeah, I think I'd go crazy deep in, like, quantum mechanics as well and be like a physicist, but maybe an astronaut or something.
That'd be
It's
cool.
probably the cliche answer, but, um
I made my grandma, a robotic car that was a replica of the car that, like, in the movie Good Will Hunting, like Matt Damon's like best friend like buys for him so that he can like drive to California. I made that for my grandma for Christmas one year and she really liked it.
That is so cool.
Yeah, I was also gonna say a gift, but, like, I made a Mother's Day gift for my mom, a bit ago. It's like a sheet metal flower and also, like, little paper plane keychain that I made out of silver casting. I'd probably say that.
That's so cute also. I think I've, like, seen similar things online of, like, the metal kind of flowers, so that's really cool.
Yeah.
What is one word to describe your time at Stanford so far?
I would use the word wait, it's not a describing word, but I think it like captures many things, which is energy.
I'd say, like, curiosity.
I think those are both great ones and super big for STEM too, so yeah.
Ooh.
So for these last couple questions, they're a little bit more like reflective. So just like about your experience so far, and what any advice that you guys have. So when someone listens to this and hears about your story and your experience, what is one thing that you hope they take away from it?
I mean, I guess never like undersell yourself. And like engineers, like if you want to be an engineer, if you even think you want to be an engineer, like engineers are not people who succeed like the first time. Like they're people that learn and fail and do things wrong and then learn a better way to do things. And so yeah, I guess like engineers are just the people that are willing to kind of stick through things and like love solving these whatever issue that may be. And there's also so many different types of engineering. Like if you say you're not interested in hands-on projects, like there's 10,000 other like engineering roles to be a part of. They're not all the same. If you're introduced to one and you don't feel like that's your avenue, there are many others as well.
And I would say, well, when I was in high school, my guidance counselor, she asked me, like, do you want to keep the science door open? And this was like going into 10th grade when you could decide to take like more science classes or not. And that question was like kind of crushing because I was like, wow, is she asking this of everyone? Like, does she ask boys if they want to keep the science door? Like, why? I don't know. This just sort of stuck out to me as like a question that underscored for me that like there's so many like ways out. Like people give you an out from science at every step of your career, I think, especially as like young women. But if you love it, like you don't have to like keep one door open and close another one. Like you can be creative, you can be artistic, you can love beautiful things, and you can also be a serious engineer. I think that knowing that like combining the things that you care about in new and interesting ways is what makes you a great engineer. I think that's something that I had to like learn the hard way that I hope that girls now know inherently.
Yeah, and I think that's a really great point, especially in the connection oftentimes between like something like engineering or STEM focused fields and humanities, whether that be like art or policy, etc. But I think a lot of the times we kind of look at them as very different, very, opposite ends of the spectrum kind of fields. But I feel like one really can't exist without the other. Like you need that social understanding to create these technical solutions. But it's oftentimes really helpful to also have like that technical expertise going into these humanities fields just because of like this very technology focused world that we're moving towards. So I think that's always a great mindset to have is that you don't have to pick one field, like you don't have to pick STEM or humanities. It can really go hand in hand. So I think that's a really great point. What's one thing about being a woman in engineering or STEM that you wish more young women knew?
It's so much fun. You'll love it. It's really awesome and great. And it's not like you don't feel out of place every day. You actually have a lot of fun.
Yeah. Yeah, it's really fun as well. Same thing, but I'm trying to think. I think kind of similar to kind of what I was saying earlier, but yeah, there's a lot of us. There's a lot of us out there rooting for you, and I think we might not know each other yet, but like we're all the same towards the same goal and we're all have something to contribute everywhere. And so, yeah, I think society and people will probably say things sometimes, maybe not. They'll give you an out, like Sophie was saying. Or people will be like, oh, if you're really good at that, like, sport, doesn't mean you could be a good engineer. Like, don't listen to those things. Nothing is like everything works together that you learn. Like, I've learned things in like from my time like playing volleyball um that have directly contributed to like how I am as a leader in engineering as well. And so I think every experience is helpful in every way. And so like you can do it all.
Yeah, I think that's a really great point about like all of your experiences are kind of interconnected regardless of what they're really focused on. And taking all those experiences and just like making yourself a better version every single day is super important. And for my very last question, if you had to give your younger self one piece of advice, what would it be?
I'd say this is like definitely not my quote, but like like I think you're gonna constantly have like voices in your head or around and like fears in general, but like confidence isn't like the absence of fear. It's the like courage of doing things when you have fears or when you're scared to do something. So I think, yeah, believe in yourself.
Yeah, I think that's a really great message. Taking like having that ability to take that leap of faith regardless of if you're scared to do it, like being comfortable being uncomfortable and just like making sure that you're going down those paths and not restricting yourself just because of, what could possibly go wrong. But yeah, that's a really great one.
I think like there are many experiences I had to go through like growing up that like helped me reach like something closer to like enlightenment or like knowing that being myself is okay. So like I wouldn't have changed that, but I think I would say that like who you are and like the creativity that you possess is like so valuable and important to the world. I think there are gonna be a lot of people who might try to, like, dull that or, like, contain it or put it in a box, but the most, like, special thing that you can do for the world is just, like, not let that happen, so, yeah, I think it takes a great deal of courage to, like, be yourself, but I ultimately arrived on the idea that the world needs us all to be exactly who we are and contribute in our own special ways.
Yeah, I think that's such an important message, especially, as like young people like going into STEM fields. It's just like having those diverse perspectives and like having that open-mindedness and bringing in like new perspectives is so important, especially in like this super evolving and developing field. So I think having like that uniqueness and like bringing something different to the table is so incredibly important. But yeah. So,
Thank you.
Sophie and Rachel, thank you guys so much for having this conversation with me. This was a great conversation. I feel like I've learned so much about, your technical experiences in solar car or your other personal projects, but also about your personal experiences as like growing into these positions and like growing into these experiences as an engineer and kind of leading more into the things that you guys are finding interesting to explore, which is exactly what I love about having these kinds of conversations. Thank you guys so much for being a part of this.
Yeah, thanks for
Thanks for being interested. It was really nice to meet you.
Yeah, it was great to meet you. And for everybody else who's listening, if this episode resonated with you, please share it with someone who you think needs to hear it as well. And leave us a review on your favorite streaming platform. Thank you so much for tuning into the She Persists podcast. And until next time, keep persisting. Once again, I'm your host, Emma Zareen, and thank you so much for tuning in to today's episode of the She Persists podcast.